Hello dear students. Okay, so in this video we are going to learn about application of differentiation, okay, in chapter 3, specifically in maximum and minimum value. Okay, so 3.3 minimum and maximum point. The application of minimum and maximum point is to find the highest point as well as the lowest point in any function. Okay, so we can use differentiation to find the highest point and the lowest point. Okay, the first derivative as well as second derivative. We will see both differentiations later. Okay, before that, let's see this one, increasing or decreasing. Okay, the shape of a graph is related to its defining equation. By analyzing the equation, we are able to determine the properties of the graph. Okay, so you have learned about slope, right? For the first derivative, okay, we know that when your slope, which is the dy dx less than 0, okay, so when your dy dx less than 0 or it is negative, then we have a decreasing slope. Okay, and then when your dy dx greater than 0, or we call it positive, then we have a increasing slope. Okay, how about constant? Constant is happen when your differentiation is equals to 0. Okay, so here we have decreasing function, increasing function, constant, and then increase again and decrease again. Okay, that makes up a graph. Okay, so let's see as this graph. Okay, we have a tangent line. The tangent line become horizontal at x equals to c if your f prime c equals to 0. Okay, so this is when the critical points occur. Okay, so here is the critical point c, here also the critical point c, here also the critical point c, and as well as here. So if you can see here, we have maximum, and then this one minimum, and then this one is not either minimum or maximum. The fourth also not a maximum or minimum. Okay, so we will come to this two later. Okay, so example 1, how to find the critical point. Find the critical points of the curve fx equals to 1 over 3x to the power of 3 minus 2x squared plus 3x plus 1. Okay, so we have the answer here, 1 7 over 3 and 3 1. So let's find okay, so let us do that to find the answer. So we have fx equals to 1 over 3x to the power of 3 minus 2x squared plus 3x plus 1. Okay, so to find the critical point, we have to differentiate our function, first derivative. So f prime x is equals to, okay, you can do this with me together. So we'll have x squared minus 4x plus 3. Then we must equate our equation equals to 0. Okay, so obviously this is a quadratic function. To solve or factorize this equation, we'll have x minus 3 x minus 1 equals to 0. Okay, in which we will have x equals to 3 and x equals to 1. Okay, so if x equals to 3 and x equals to 1, how about fx? Okay, so if x equals to 3, then we will have our f3 or fx equals to 1 over 3 to the power of 3 minus 2 3 to the power of 2 plus 3 plus 1. Okay, in which we will have equals to 1. And if x equals to 1, we'll have f1 equals to 1 over 3 1 to the power of 3 minus 2 which is equals to 7 over 3. Therefore, our critical points, we have 2 points here. The first one is 3, 1, and the second one is 1, 7/3. Okay, so remember our critical point must be in terms of x, fx. Okay, so let's see the first theorem. Let f be a continuous function on the interval a, b. Okay, the range of from a to b, the domain from a to b. Then f is increasing if your first derivative, which is the f prime x, greater than 0. Okay, so as I said before, for f prime greater than 0 means your slope is positive, so it's increasing. Okay, and b, if your f prime less than 0, so you have a negative value, then your slope is decreasing. And then if your f prime is equals to 0, then you have a constant. Okay, so this is concave, convex. There is another useful way to describe a curve, that is convexity and concavity. A curve is said to be concave at the point P if at the neighborhood of point P, so let's say point P here, okay, the curve lies above the tangent line at the point P, otherwise it is convex. Okay, so this is the tangent line lies above the curve. The curve is above the tangent line. This is tangent line. Meanwhile, for convex, okay, the curve lies below the tangent line. Okay, then critical values. Before we determine either there's a maximum or minimum value, we have to find the critical value first. Okay, so a point CFC, so C is the value of x here, and then FC is the value of y. A point CFC of the function fx is a critical values if f prime c equals to 0 or if does not exist. If you still remember, as I said before, f prime c equals to 0 means you have a constant slope. Okay, so means here you can find the critical, you can find the maximum or minimum on your critical point. So this is your critical point, here is your critical point, C also your critical point, D also your critical point, and E is your critical point. So all dot here is a critical points. So if f prime is a quadratic function or function of higher order, then there's possibility of having more than one critical values, as in this example. Okay, so either the point minimum or maximum, that will be determined using the theorem or test letter. So this is the first derivative test to determine either the critical point is a minimum point or a maximum point. So suppose C is the critical point. If f prime changes from positive to negative at C, then f has a relative maxima. Changes from positive to negative means, okay, your slope from increasing and then it's decrease. So here is your maximum. Okay, so B, if f prime changes from negative to positive at C, then f have a relative minima. So same explanation. from negative to positive means decreasing and then it become increasing. So point C here is a minimum. If f prime does not change in sign at C, then f has no relative maxima or minima at C. Okay, if either it is positive or negative and then negative again, so we say it has no relative maxima or minima. Okay, let's see example 1. Find all the critical points of the curve and determine their nature using the first derivative test. Okay, so we have f x equals x squared minus 4x minus 1. So first of all, we have to find the critical point. So if you still remember, to find the critical point, we have to differentiate your function for the first derivative. Find the first derivative. So 2x minus 4, then equal it equals to 0. Then you'll have your x equals to 2. Okay, so if your x equals to 2, then your f2 or fx equals to 2 will be negative 5. Okay, so your critical point is negative 5. X equals to 2 is here. Let's say the before points we pick x equals to 1, and then the after point is we pick x equals to 3. So this is our f prime x. Okay, we will see either it's minimum, maximum, or neither. Okay, so we have known that if our f prime x equals to 2, then we have our f prime 2 equals to 0, which is the slope will be constant. Okay, so if we have f prime 1, then I will have 2 1 minus 4, which is will be negative 2. So negative 2 is a negative value, so slope will be decreasing. And then if I have f prime 3, then I will have 2 times 3 minus 4, which is 2. And then the value of 2 is a positive value, then we will have our slope as increasing. Okay, so if you have a negative value, okay, and then your function change to positive value after the critical point, then we'll have minimum at to negative 5. Or you can see from the pattern here, okay, negative and then become positive, so obviously this one is the minimum. Okay, let's look into second example, which is 1b. So we have here absolute value function, okay, fx equals to absolute value of x. Okay, so we know this function. If you sketch the function, you'll have this graph. Okay, so it does not have a negative value. Okay, what you have is a positive value where the negative part reflected to positive, okay, value of y. Oh, this is fx. Okay, so from here you can see that this is your critical point, in which when your x equals to 0. Okay, so when your x equals to 0, your f0 also will be equals to 0. So you will have critical point as 0 0. Then as you can see from the graph also, this is the minimum value. Okay, we test for using the first derivative test. So we have x equals to 0. Let's say we take a value of x equals to negative 1 and x equals to 1. Okay, to see the pattern of our f prime x, either it's increasing, decreasing, or constant. Okay, so okay, so this is the critical point. critical point. Okay, so when your x equals to -1, your f prime x will be equals to either 1 or -1 when your x is greater than 0 or your x is less than 0, right? Okay, so the slope is positive if your x is greater than 0, and your slope is negative when your x is less than 0. So yang ini x equals to -1 is obviously less than 0. So this is your fx equals to -1. Here your fx equals to 1, which is the slope will be decreasing and then increasing. Okay, so the pattern of increasing and then decreasing means you have a minimum at your critical point, which is 0, 0. Okay, our last example for this topic. Okay, example 1c. The function is fx equals to x to the power of 3 minus 2x squared plus x. Okay, so again, first step is to find the critical point or points. Okay, you may have more than one critical point. Okay, so we find the f prime x, which is equals to 3x to the power of 2 minus 4x plus 1, then it equals to 0. Okay, so since this is a quadratic function, so we may have more than one critical point. Okay, x plus 1, so obviously we will have more than one critical point here. Okay, so you can use your calculator to find for the roots of x. Okay, so I find here my x will be equals to 1, and another one is x equals to 1/3. Okay, so my fx, if my x equals to 1, then my f1 will be zero, and then if my x equals to 1/3, my f1/3 will be will be 4/27. Okay, so we test for the fourth critical point with x equals to 1/3, and then x equals to 1. Okay, then we find the in between 1/3 to 1, as well as greater than 1 and less than 1/3. So let's say we find the x equals to 0. Here we take x equals to 1/2, and then here x equals to 2. Okay, so let's see the pattern of f prime x. Okay, if your x equals to 0, the f prime x will be f prime 0, which is 3 minus 4, 0 plus 1 equals to 1. Then it is a 1 is a positive, then the slope will be increasing. If your f prime 1/2, then you have -1/4. And so -1/4 is negative slope, which will be decreasing. And then lastly, when you f prime equals to 2, then we'll have then 5 again increase, then have a positive slope. Okay, so obviously here we will have a maximum, and here we have a minimum. So you can conclude we have a maximum at 1/3 4/27 and minimum at 1 0. Okay, so that's it for this video. You have learned how to find maximum and minimum point, how to determine the maximum and minimum point using first derivative test. Okay, so I left you with this exercise. Okay, if you can see from the graph here. Okay, so you know that this is the maximum point, and then this one will be the minimum point. Okay, so please find the maximum point value and the minimum point value. Okay, so remember, you have to find the critical point first and then determine either the critical point, maximum, minimum, or neither. Okay, so the maximum here, I give you the answer. The maximum here is -5.77, and then the minimum here is 0.331.148. Okay, that's it. Thank you, students. I hope you have learned something from this video, and till we meet again on other video. Thank you.